Chris, who is from the Satellite Applications Catapult, and he's actually going to talk about how Satellite Applications Catapult is helping us making our lives easier. So I think that's quite a nice start. So Chris McNeil, so it's over to you.
Cool. Thank you very much for the introduction. I should say it's actually not about how I'm helping make your life easier, although hopefully, like maybe in some way we will. It's more about STAC, how we're using it to make our lives easier. So before I go into detail about STAC and what we're interested in about it and what we're doing with it, just a sort of quick introduction. So yeah, I'm a geospatial solutions architect at the Satellite Applications Catapult. Who are the Satellite Applications Catapult? So we're mostly based down south, down near Oxford, but we're a not-for-profit innovation and technology company transforming the way the world uses satellite technology and data. So basically, we're trying to catalyze the use of space in the UK primarily. What that means as an organization is we actually work across sort of several different angles, end-to-end really. So some of my colleagues are doing really cool things like, you know, designing and building rocket engines and actually flinging bits of metal up into space. Some of them are looking at like position, navigation and time, connectivity, satellite, 5G, all that sort of thing. But the team I'm actually in is the geospatial intelligence team. And what we tend to focus on is the application of Earth observation data across all sorts of areas, really, whether it's agriculture, health, mining, all sorts of things, really. So what's our role in all this? So, you know, as a team, what we're interested in doing is sort of energizing the market. So what we tend to do is face into different companies, different projects, different organizations, and try and see what we can do to get them to be doing more with Earth observation, or see if there's anything that they're doing that Earth observation could play a role in. Trying to drive forward technology. So if there are new things that we could be doing or helping other people do with Earth observation data, then we want to be trying to sort of insert the technology to make that happen. And then as well, you know, of course, it's all well and good, the technology, but obviously there's the money angle as well. So enabling businesses to do more with Earth observation and make more from it. So the geospatial intelligence team, so what are we specifically doing? Yeah, so we're accelerating the adoption of geospatial analytics into business processing at scale that drives value across industries globally. That's the tagline. But really what that means is, you know, us doing things like getting involved in Pulse 4G, you know, looking across the market at interesting things happening in EO, providing steer on kind of strategic level things of EO in the UK. And looking at investment for transformative innovation projects. So what that means is really, so me and my team, I'm a geospatial solutions architect. We've got a couple other architects, but mostly it's a team of, we've got a software developer, but then it's all GIS, Earth observation professionals. So people who, you know a lot more about working with data and playing with GIS than I do. But they're working across a huge range of different areas. And of course, a huge range of different areas means lots and lots of different types of data coming from lots and lots of different types of places. So, you know, what that means is from a sort of satellite point of view, we're working with, sure, lots of open data. So whether that's Sentinel-1, Sentinel-2, Landsat, you know, the large missions where all the data is available publicly. There's a lot you can do with that. But also trying to work with commercial data, help other companies do more with commercial data, and applying things like data from Maxar, Planet, Airbus, and many, 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 many more. Then, of course, we're taking all those different types of data from all those different sources and processing them in a lot of different ways. You know, with every satellite, kind of feels like you've got to apply a different tool to actually process that information into something that's maybe more analysis ready. But then in terms of actually working with your data, you know, you could be doing something in Python on a computer, you could be doing it in R, we could be deploying it to the cloud, maybe doing some work with GPUs. Some of my colleagues might be using Google Earth Engine. And then finally, you know, we're serving that data up to customers or you know, we're helping people serve up data to their customers in many, 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 many different ways, whether they are building platforms to deliver data or websites or reports, There's many different ways in which people are going to be taking this data that's coming all the way through from these satellites. So I guess the thing is, wouldn't it be great if there was an open standard for managing all of this data that people could agree on to make everyone's life easier? And of course, this is where STAC comes in. Now, I called my talk, yet another talk, because I feel like STAC is a topic that's been coming up a lot at FOSS4G, at least over the last couple of years. The STAC spec was finalized only last year. I'm not going to do a deep dive on STAC because there are people that know a lot more than me who will do a much better job of that. But I'm going to just tell you quickly like what it is and how STAC sort of starts to build an ecosystem of tooling and approaches that we think you can do some really, really cool stuff with. And we've been kind of building some things to kind of help plug into that ecosystem. So STAC stands for Spatiotemporal Asset Catalogs. Basically, it's essentially just a metadata specification. So if you've got a spatiotemporal asset, basically what we're talking about is some raster data from a satellite. You've got a Sentinel-2 scene, or you've got a picture that's come from Planet or something like that. It's a metadata specification for describing that asset. And then usually what you do is you take that asset, you take your metadata, and you go stick it in the cloud somewhere where you can access it. But just that kind of simple idea unlocks a ton of stuff that we've not necessarily been able to do easily with Earth observation data until recently. So what it begins to unlock, if you are an Earth observation data provider, it's the Copernicus program, or if you're Planet or Maxar, you can deliver some data to someone, and when they receive that data, and it's metadata, crucially, it's all in a format that they already know how to use. So you can just drop it straight into their data processing pipeline or into their data repository, and they're not having to build a separate ETL pipeline for the data that they're getting for ESA and for the data that they're getting for Maxar. Then if you're a developer perhaps, and you've now got this repository of data, again, some of it might be from Maxar, some of it might be from Copernicus, you can build reusable tools that are able to kind of pull the metadata out of each of those different data sources. And again, you're not having to worry about ETL, you're not having to worry about having to build a different tool for a different use case. So you just have to build something once, which is great. And then for your users on the other end, they again get the benefit of all that time that's been saved upstream and all of the common tooling that you've been able to build around this common specification. So in an ideal world, everyone who is publishing raster information would be doing it with the STAC spec. Everyone who is building data management software would be using the STAC spec, and everything from QGIS to Esri to every sort of library would be able to read the STAC spec, and we'd have this beautiful world where everything can talk to each other. With STAC, there's a lot that you can already start to do. The way that the STAC is, you can build a STAC with STAC. And the way that the STAC spec kind of fits together is it's very sort of plug and play, and you can kind of build what you need to build, really. So if you're trying to put together a solution to meet someone's needs, you can, pick the bits and pieces that you need to deliver that solution. So by building a data store that's got all of that data in it, and you just, you chuck it up in the cloud and it's nice and simple to manage. You can build your metadata catalog on top of that, and some people can interact with that metadata catalog directly, or you can load that metadata into an API, and now you've got an API that you can expose to a user directly, or maybe into an application, or again, with that API, you could build an application on top of that. So depending on what your use cases are, you could have a very, very, very lightweight application of this, or you can build something that starts to look like a really, big bespoke COTS application. If you have a look on the STAC website, they've got a huge list of sort of ecosystem pieces that plug into STAC, and it's everything from Python libraries for being able to trawl through the data and find the raster assets that you need. There's a QGIS plugin. There are browsers, so you can go look at someone else's STAC API and see what data they've put inside it. There's tools for loading and validating. There's one called T-Tiler, which is you've got this data set and you've got this metadata, and on top of that, you can build a XYZ or WMTS tile server. So, you're taking all these pieces, and what would have taken a rather large, heavy, expensive, proprietary image server solution in the past, you've now been able to kind of build entirely from open source parts that, most importantly, will scale nice and easily across the cloud. And there are some really great examples out there now of people who have built lovely applications that have been built around the STAC architecture. And the Microsoft Planetary Computer Data Explorer is one that I'm quite a fan of. If you've not looked at it, they've basically got this huge repository of open data. So everything from like Modis, Sentinel-2, the weird ones like Sentinel-3, which you can access and browse. So if you've got projects where you're processing huge amounts of data, you can just use the data that they've got there already. But then they've built this lovely application on top of it for actually browsing the data. So it's a really nice example of how you can build something around this ecosystem. And this is what we wanted to do as a team, right? We wanted to build up our own sort of STAC data repository where all of those various raster assets that we were retrieving from these various satellite sources and using in all these different projects, we could find a way to organize them and sort them and look after them, really, and manage them and access them. But the problem we started to run into really is, well, how do we actually get that data into our system? And when I showed that slide where you've got your data suppliers using STAC, the problem is right now, as we find, is that a lot of the data that we're bringing in isn't STAC compliant yet. Maxar and Planet are like interested in doing it, but not all of their product offerings support that. So for our team, that's something that was eating up a lot of time. So what we set out to do then was to build a tool that our Earth observation consultants, our GI consultants could use. And basically, with all that data that they're handling already, we wanted to give them somewhere where they could put the data that would get into the STAC ecosystem and then be able to interface with all those sort of tools that plug into that downstream. So we worked with Spatial Days to help deliver this. So they're based down in Aldermaston. I think they're attending FOSS4G in Cardiff today. So if anyone down there sees them, say hello. But what they helped us build is just a sort of lightweight application that we could deploy in our Azure environment. So apologies for Alistair's talk. I'm showing you all different icons, and obviously the problem with the cloud is that they all do basically the same thing, but they all use completely different icons to do it. But what we were trying to do was something that was lightweight and used the best available open source components. So we've brought together lots of things that you might have seen already. So like the STAC browser, the STAC Fast API, and GDAL, of course. And we deployed them into containers. This blobby icon there is an Azure application service, and that's just basically something for you to run Docker containers, essentially. And what's nice is it gives you a couple of wrappers around it that help you do things like manage domains and security and access. So, we wanted to keep the application minimal, but where we could make use of the cloud features to make our lives easier, we used that. We've got a Postgres database for storing all the data, and then all of our various raster assets, they're going into the sort of storage account, the blob stores, as Microsoft calls it, or S3 bucket, if you're more familiar with the AWS terminology. So that's the application. What I'm going to do now is something brave or maybe stupid and try and give a demo of how it works. And hopefully I'll be able to show you how this helps with our data management. So is that still showing?
It's on the feed.
Okay.
I think you must have done a presenter mode thing.
Should I just unplug this and plug it back in?
Why not?
I think it's just like having to.
Oh, okay.
Extended your desktop.
Yeah. Click on the stream.
What were you using to present?
Right. Okay. We're back. Okay, so this is our application then. I think one thing that was quite handy for us is we were able to deploy it in Azure. Before we had lots and lots of raster assets that were on-prem, and it made it really difficult for like a distributed team to access over VPN and that sort of thing. But now we've got something that we can access from anywhere, including here. So there's kind of two things that this application does that are oriented around loading up a STAC catalog with the data that you need. The first one is trying to make use of all the data that's already available in these open source repositories. So, you know, Sentinel-2, for example, I would say no one should ever have to manage Sentinel-2 data again, because Microsoft, AWS, they're all doing it all for us. We can save a bunch of time by just making use of the data that they have available. But for a given project, I might not need the entire archive. So what we've got is the ability to just like load up a collection of data that covers just a specific area and a specific date and time. So say, for example, I was starting a project where I needed just the data over Scotland for the last 2 years to create a classified land cover product or something like that. I can pop that search in, and now what it's gone is it's trawled through different open catalogs that have got data that cover that area. So let's see, I'm going to go find, we've got Landsat from Microsoft Planetary Computer. So I'll take that and I'm just going to load that into my catalog. Depending on how big that is, that might take a wee while, but what we've got is we've just plugged in the STAC browser. This is a fantastic sort of open source tool. You know, you can just point this to any STAC API, and suddenly you've gone from, you know, an API to a really good looking, you know, GUI basically that is on par with, you know, some really nice like web front ends. And you know, now it means in a project we don't have to ever worry about building a front end for managing this kind of data again, because there's a fantastic open source project that we can just plug into our library. There we go. Here's a nice Landsat tile. There we go. And because it's come down from a STAC catalog, it's got tons and tons of data in it. We've got all the different bands, and I could just download this scene straight away. Or if I was in QGIS, I could plug my QGIS API, STAC API browser into that. So that's all loaded up. Any data that I need for Scotland is basically now ready to go. The next thing we've got is, you know, we've got open data is great, but sometimes you need to go buy some expensive high resolution imagery from someone like Maxar. And that's something we often do a lot. The data is delivered in these, you know, folders with just lots of, you know, it looks like junk really. You've got your licenses in there and your readmes and some shape files and some delivery metadata. It's a bit of a fuss to manage and trawl through. So what we can do is we can just drag that into the interface. This is where we pray to the demo gods that this works. Yeah, here we go. So it's trawling through that. It's looked for a manifest file. It's parsing through that. And what it's doing is uploading it to the Azure account. It's going to pop it in there. It's doing a call off to, so it's looking for metadata from two places, basically. It's using any metadata that's included in the file, so in that manifest file, but also GDAL info is now capable of reading your rasters and spitting out the metadata in a STAC compliant format, which is really, really neat. In using that, that saved us a ton of time. So this is the bit that was being a bit funny on this Wi-Fi earlier. Okay. So yeah, so what that should do is read in the files and spit out from this mess my STAC compliant metadata, and then I would just hit publish, and it would show me that in the catalog. of course, again, we've got our STAC browser. STAC browser is just one view of that API. If I was using my PyStack library in a Jupyter notebook, if I was using the API, I'd see the same data set. But I've got all the stuff that Maxar supplied us in our order now all here with some STAC compliant metadata. So now, rather than a mess of files on a computer that someone's having to move around on a NAS drive and that sort of thing, we've got files that the team can manage, that they can share, that they can search through, that they can filter. You know, they can do things like filter by cloud cover, acquisition date, and for us, you know, and I keep talking about how STAC is making our lives easier. At least, you know, we've now gone from a mess of files on a NAS drive to a catalog that's actually searchable that we can use. Most importantly, we can just build what we need. You know, we don't have to buy a huge commercial off-the-shelf system to do our data management. We're able to kind of piece together these free, extensible, open source pieces. So just to wrap that up then. So, you know, where have we got to with STAC? So the actual STAC specification, as I said, it was only finalized a year ago, but I think it's getting, I'd say, alarmingly easy to build platforms that can compete with some commercial off-the-shelf offerings in terms of managing raster assets and serving up raster assets. But of course, more vendor engagement with things like STAC would make everyone's life easier. You know, there are some big organizations out there that don't currently support STAC, so it would be great if they did as well. So what do we want to do next? Well, this is just version 1 of this piece of software. We want it to plug into like more of our data providers, so it fits into more of our projects. And you know, we want to start to do things like maybe layer on like fine-grained access control. So I, for example, could be, you know, collaborating with you, and I just send you a link to my collection that I've got in my store, and then you can access the raster assets in there, but I can keep everything else hidden from you. And you know, it'd be really nice for some of this data that we're getting as well. It's not being delivered by everyone in cloud optimized GeoTIFF. So when we upload it, if we could transform it into a cloud optimized GeoTIFF, that would be great. So just flipping back to this slide. So, you know, what do we want to do with this? So we're, of course, open sourcing all of this work that we've done so that anyone else can hopefully pick it up and do something useful, hopefully. I feel like I did learn a lot from this morning from Tim's talk. Maybe open source projects aren't necessarily that easy. So, you know, go easy on us. This is the first open source project that we've released. The code will be appearing on our GitHub at some time in the next couple of weeks. We're just sort of wrapping up the delivery. But yeah, any feedback, any comments, any contributions, or anyone that wants to make use of that, yeah, please do feel free. But yeah, if you want to get in touch with us or Spatial Days, there's my details there. So yeah, that's me. Thanks for listening. If you've got any questions, happy to answer them.
Okay, any questions or Chris?
Yeah, just because is that actually a service you're providing at the moment for people to access properly? Or well, what's the sort of business model there at the moment?
So what we've built is like a platform for our team to use,
right,
like internally. So it's not a piece of software that we're selling or anything. But you know, everything I showed you is open source. So you could go deploy your own STAC portal on your own infrastructure. You know, and the reason why we made it open source is so many projects that we go into as well will work with like a different company, a different like system integrator, and we want to be able to just hand them over some code that they can implement for a customer as well. So if you wanted to build a service using that, you could.
Okay. So just out of curiosity, because you're currently sucking in lots and lots of data, I suppose. So what's your sort of storage cost?
So with the open data, it doesn't actually suck in the data, it's just sucking in the metadata.
Right.
So with all of that Landsat data that I showed pulling down from Microsoft, we're just copying the metadata and it's pointing to the actual data still stored on Microsoft servers. For our own data, you know, we've got a few terabytes of data that we want to get into the system, but with cloud storage, you know, that's only going to be costing you £100 a month, maybe. It's quite cost effective to use cloud storage for storing raster assets.
Any other question?
So
I'm
what's the license?
sensing.
What's the license that you're going to use?
We're just doing a review on that with Spatial Days, but we're gonna go for something as permissive as possible, really. We're not trying to like hold on to this. I can't remember what we've decided, but
And I suppose the last question then is, how long are you going to support it? Because I mean, you're basically open sourcing it, but is that just a code dump, or is it something that you're going to support for the next few years?
Yeah.
What's your funding for this?
so our intention is to use this in like internal and external projects that we've got for, at least the next, I've got projects in mind that we'll be able to use it for the sort of next 6 to 12 months. So we'll still be making use of this for our own purposes. So we'll be keeping it maintained during that. And hopefully we'll be able to get more, longer term support for it after that.
Sorry, I'm hopping this. This the STAC metadata. Have you sort of standardized this somehow? Because I mean, it just reminds me of the XKCD cartoon that you probably know about. That there are N standards out there. We need to have a standard that fixes everything. So now there are N+1 standards. So what makes this the one to go for?
I would say so. I've not been involved in any way contributing to the STAC specification. That's something that's been done by others. I think the STAC specification fills a gap in metadata specifications. So, if you look at like OGC, you've got like your web feature service, you've got WMS, WMTS, but there's not really anything particularly good within OGC for looking after catalogs of, and I keep saying sorry? Yeah. Yeah. But STAC's been adopted by OGC anyway, so the specification is going to still be maintained by OGC, and within parts of this spec, once you get to like the low level, it's aligned with the web feature specification anyway. So it's a, it's a sort of full member of, I guess you could say, the OGC family, and OGC specifications tend to be well adopted.
Any other question? I don't know why I'm sensing you want to ask something that you change your mind, but okay.
Sorry.
Oh, sorry, I pushed you to.
We could do it.
Yeah, I think the next one is going to be the national
Yes,
one.
yeah,
So we need to be on time, and we've got 3 minutes. So I should also apologize